Hello student, this video lecture is prepared for the subject heat transfer for diploma students, and I will discuss the unit number 6, that is known as evaporation. So in previous lectures I had discussed about material balance of single effect evaporator, and today's lecture I will discuss the next part, that is known as the enthalpy balance or heat balance for single effect evaporator. Then we will discuss the evaporator types, and then we discuss one by one the different types of evaporator. For example, open pan evaporator, horizontal tube, calandria type, or standard vertical tube evaporator. So let us start the lecture. So in previous lecture we had concluded this material balance of the solute. Then we will move to the enthalpy balance or heat balance. So before going to the heat balance, we have to note some parameters or nomenclature. So let Tf is the temperature of feed entering in the evaporator. So this is the feed entering in the evaporator. That evaporator is having temperature which is denoted by letter Tf. So this is Tf. Then capital T is the temperature of the solution in the evaporator. So this is the solution which is present in evaporator. This solution is having temperature T, and Ts, that means temperature of condensing steam. So here we are adding the steam. So this temperature is called Ts. Okay. So you should note carefully these temperatures, because these temperatures are required in calculation in the problem. So Tf is feed temperature, T is the solution temperature, and Ts is the steam temperature or condensing steam temperature. So heat transfer to the solution in the evaporator by condensing steam. That means we are heating that liquid by condensing steam. That steam is utilized to heat the solution from Tf to T. That means feed temperature to the boiling point of that solution, or vaporization, for the vaporization of water from the solution. Then we can write the heat balance. So how we can write the heat balance? Heat lost by condensing steam, that is latent heat. Okay, that means when the steam is giving heat, so it is lost, and this lost steam is equal to heat gained by solution to increase the temperature to boiling point. That means first part of that heat is used to increase the temperature of the solution to its boiling point. Okay, and then after the boiling point is reached, then remaining heat is used for vaporization of water or evaporation of water. Okay, that means suppose here if you feed the steam, then first heat is used for increase the temperature of this solution, that is up to T, and then remaining heat is used to evaporate the water from vapor outlet. Okay, so this is input heat, this is output heat. So at steady state both heat are equal, input is equal to output. Then how the loss of steam, loss of heat is given. So we are having formula m dot s lambda s, so which is equal to q. So this is q. So where m dot s is nothing but the mass flow rate of that steam, and lambda is s is the latent heat of that steam. Okay, so this is the nomenclature we can use in that condition. Okay, so m dot s is the mass flow rate of the steam, and lambda s, this lambda s is the latent heat of condensation of steam at a given temperature, which is equal to heat gained by the solution to increase the temperature to boiling point. So how this heat gain is given? M dot F, that means mass flow rate of feed, multiply by CPF, that means specific heat of the feed. So this value is given in the problem while solving. Then T is the temperature of that solution minus TF, that means temperature of feed. So if we multiply all this quantity, we get heat gain by solution to increase the temperature to its boiling point. Okay. Then plus heat required to vaporize the or evaporate the water. So what is mean by this? So it is given by m dot v. So m dot v is nothing but water evaporated. M dot v is nothing but kg per hour of water evaporated, multiply by lambda. So this lambda is nothing but latent heat of vaporization of water at a given temperature. Okay. So by multiplying these two quantities, so this is actually m dot v multiplied by lambda. So this is not double. Okay, just plus m dot v lambda. So this is given heat required to evaporate the water. Okay, so by doing this we can write the or calculate the sometimes m dot s by giving all these value. So this is called a enthalpy balance or heat balance for the evaporator, and in previous case this is called a material balance. So this equation and this equation we can use for calculation purpose. Again, we have already learned that the boiling point elevation. So boiling point elevation should be added in the boiling point of water. So by addition of these two, we get the boiling point of the solution. That means if we are having T dash is the boiling point of a water at a certain pressure of the operation, that means pure water boiling point, and then we have to add the boiling point elevation. Okay, so if we add this boiling point elevation in that boiling point of the water, we get the boiling point of the solution. That means this T we can get by addition of elevation. Okay, and we have already understand the definition or learn the definition of boiling point elevation. Okay, so boiling point elevation is nothing but it is the difference between boiling point of the solution and that of pure water at a given pressure. So sometimes it may be given or sometimes you have to calculate in that problem. So that we will discuss while solving the problem. Then again you have to calculate the area of heat transfer required for the evaporator. Okay, so how that should be calculated? So we have already seen this equation, Q is equal to UA delta T. So how Q is calculated? We have already discussed that Q is equal to m dot lambda s. M dot s multiplied by lambda s means steam feed rate multiplied by latent heat of condensation of steam. That means this quantity we have to feed here. Okay. And U, that means overall heat transfer in that problem is given, the overall heat transfer coefficient. Then A, we have to calculate that area, and delta T is nothing but the temperature difference. But this temperature difference is important. What is that temperature difference? It is the Ts minus T. That means condensing steam temperature minus boiling point of the solution. So this gives the delta T. Okay. So the temperature parameters are important here. You must clear this idea where what is meant by T, what is meant by TF, what is meant by TS, and what is meant by delta T. Okay. Then we will discuss the units. Q is in watt, U, that is overall heat transfer coefficient, in watt per meter square Kelvin. Delta T is also given in Kelvin, and area you have to calculate in meter square. Okay. And this lambda s, we have already discussed that it is the specific enthalpy of saturated steam. So this is called a material balance and energy balance of evaporator. For single evaporator, we are doing this for only one evaporator, that is single evaporator. Then we will discuss what are the types of evaporators. So there are two types of evaporators, natural circulation evaporators and forced circulation evaporators. So in natural circulation evaporators generally used for simple evaporation operations like horizontal tube evaporator, sometimes it is called. There is another type known as the vertical tube evaporator. Okay. So this is the natural circulation evaporator. And in case of forced circulation evaporator, so these are used for salting. That means some solutions are having salt or viscous or scale formation solutions. Okay, that means it contains some water which is maybe hard or contains some salt or sometimes viscous. For that purpose, we have to use the forced circulation evaporator. And in case of forced circulation evaporator, we are using external horizontal vertical heating element. That means external heating is done in this forced circulation evaporator. Okay. So in case of natural circulation, the circulation of that solution is naturally. Okay. That means for simple evaporation we are using this, and in forced circulation we are using for liquids like containing salt, viscous or scale formation. So we will discuss one by one different types of a evaporator in the next lecture. So today's lecture we have discussed only how to calculate the heat balance, and then we have discussed how to calculate the boiling point of the solution by using P and T dash. Then Q, U is equal to UA delta T. And end of this lecture we have discussed that there are two types, natural circulation and forced circulation evaporators. The remaining part we will discuss in the next lecture. Thanks.